Very warm welcome to Storage Area Network third session. In the previous section, we talked about how the fiber channel has been connected along with point-to-point communication, as well as we discussed about fiber channel arbitrary lobes, how by using a fiber channel arbitrary lobe has been connected, and how the switches through the switch the fiber channels has been connected. Like that, the connectivity of the fiber channel has been discussed along with few concepts, something called fiber channel ports, something like N port, E port, F port and G ports, like that. So also we have discussed different types of concepts, something called fiber channel addressing and worldwide names, and different concepts, something called how the fiber channels are having a different types of ports, something like fiber logins and fiber names and fiber management, like that. So today we are discussing about discuss the extension of the previous class which we have discussed. Okay. So previous class what I have discussed I have conveyed, that means we have discussed about fiber channel connectivity, like that. Today I will extend the fiber channel connectivity by taking the concept of how our fiber channels are architect. Okay, so we discussed about we will discuss today regarding the fiber channel architecture. Okay, fiber channel architectures. Okay, so what do you mean by that? That means these any storage, any devices, okay, any system needs to be connected between one computer, connecting between one computer to the another computers along with some architecture. That means it should have a corresponding inputs and it should have a corresponding outputs. So these inputs are being defined clearly, which layer it will take the input and what is the performance, like that. Okay, so we used to connect our devices along with the application softwares and as well as the peripheral devices, so something like small computers, simple interface protocols, like that. Along with that, we different types of protocols we are connecting along with some hardware devices as well as some software devices we are using for connecting. Okay, so along with such type of connection is called as fiber channel protocols. So some set of rules we are connecting the devices, fiber channel connections along with the other devices. If you are performing the connections between the fiber channels, it can transmit with the high bandwidth for a long distance, and it can support 15 million devices through the network addresses, and the speed is up to 16 gigabits per second, like that. Okay, now let us understand what are the protocol stacks it is being used. Okay, what are the protocol stack, how our fiber channel is being defined, the architecture is defined along with the protocol stacks. Okay, so you know that we are dividing the infrastructure connections within different channels, okay, different layers. Okay, we have something called upper layer. Okay, upper layer protocols. So these are the hardware components, are the systems we are using it. Upper layer protocols, we are using something called small computer, simple interface, small computer, simple interface, like that. Or else we can use something called ATM, okay, asynchronous mode transfer, and internet protocol, and the enterprises system protocol, like that. Enterprises system protocol. Like that, these are the different types of hardware port we are using in the host machines for connecting. Okay, so the second thing is whatever the connection which done with the hardware components has to be mapped with the protocols. Okay, that means set of rules we need to map. These are the hardware devices we need to map with the upper layer protocol mapping. Okay, so since we are connecting with the devices, this upper layer mapping protocol which we have to use it through the different types of mapping we need to connect. Okay, mapping protocols, we are using different types of mapping protocol of connecting this. So this mapping protocol is been, we call it as fiber channel 4. Okay, and this fiber channel mapping protocol has been connected for the transferring the elements. Okay, so for transferring the elements by connecting between one devices to the another devices is done through the framing, or we call it as flow controls. Okay, we use a flow control concepts in the fiber channel 3 for making a flow control, that means collision avoidance and all. So in the fiber channel 2 we are using encoding and decoding operations. Okay, so encoding and decoding operations, since we know that whenever we are using a transmissions of the data has to be encapsulated and it has to be removed. Okay, so this data is in turn connecting to the physical machines. Okay, physical machines along with the port, and these physical devices, okay, is called as fiber channel 0. So these fiber channel 0 is look in terms of bitwise. Okay, either in zeros and ones. Okay, the data may be transmissions per 1 gigabytes per seconds and 2 gigabits per seconds and 4 gigabits per second, so and 8 gigabits per second. Okay, or else 16 gigabits per second. Like that, the data transmissions in the physical layer, which is called as fiber channel 0, will be looking like this. Okay, so this is nothing but a protocol stack. Okay, this is a fiber channel protocol stack. So let us understand how actually each layer will looks. In the layer 4, we are using a mapping protocols, mapping to the lower protocols. We are using a standard protocols like simple computers, small scale simple computers like that, or else we are using a high performance parallel interfaces, we are using it, and we are using high performance parallel interfaces, or else enterprises storage connectivity devices, or asynchronous mode transmissions and IP mode transmissions, like that. So we have defined the connecting between the host machines to the infrastructures, storage area infrastructures, along with some standard protocols. This standard protocol has to map to the lower protocols. That means it should be represented in the form of frames or in the flow controls, like that. For mapping, we need a interface devices. Okay, interface layer, interfacing between the upper layer as well as the lower layer, like that. So the next layer is used to have some represent the information in the form of frames as well as the flow controls. So what actually this representing of the informations in the form of frames and flow control means, that means the data which is communicating between the host machine as well as the infrastructures as well as the data centers is done through the addressings. Okay, so that means each devices in the infrastructures is connecting through the addresses. Okay, is connecting to the addresses. So that means each devices is having an addresses. Along with the addresses, it should follow some corresponding structures. It cannot be transmitted the data as it is. It should follow some corresponding structures. So and also organizations. So the data and how it is organized like that. Let us understand these concepts very well. That means the data which is transmitting from one place to the another places, it should be having some frames in the form of frames, and it should have some sequence number, and it should have an exchanging of informations like that. So that means these layer will provide the fiber services, and it will tell what type of classes of services it is providing. Sometimes some data has to be secured services, and the flow control should be there. That means the data which is flowed should be identified with the shortest path of transmissions between the host machine as well as the data centers, and it has by using an infrastructures in the storage area networks, and also it has to route it. Okay, the routing performance and the flow control performance by using a proper addressing and the structures is managed in the layer, these layers. In the last layer, which is used as a encoding layer, this encoding layer is used for grouping of our data into different secured aspects. Assume that if you have a data of 8 bits, so another 2 bits is added for the for securing the data, so that other person cannot be access it. Okay, so this type of encoding and for transmitting the data, for securing the informations, along with some source address and destination address and the routing and sequencing address like that in the different layer, is called as encoding operation. Sometimes if you want to recover, so in the receiving side we receive the 10 bytes of data, and we remove the another 2 bytes of data by using the concept of encode, and we access the data. So like that, in the last layer, so it is a physical interfaces. So both this is something like a cable connections. Okay, earlier this is the port connection, this is software connections, this is software, this is actually cable connections. Through the electrical wires, it has to identify the electric parameters and data variations parameters like that. So and as well as some optical medias also should be known. Okay, now we have understood that we have something called an address. This address in the storage area networks is divided into different types of divisions. Okay, different types of divisions. Something like we are dividing the this address into different. One is a domain ID, so which will be of some bits, around 8 bits of data is reserved for the domain ID. So and the another bits of data is used for the area ID. So since we are connecting our data, like for example if it is a servers, okay, if it is a server, so each server will be having a domain ID. So domain ID, so and each domain ID is connecting with the storage area networks. Okay, storage area networks, this is the area ID, so it is having another 8 bits of data. So this is 1 bit of data, and each port, okay, which is connecting is having something called port ID. So it's a unique ID, it is having another 8 bits of data. That means around 65 bits of data are connecting to each devices. So each devices, something like in this storage area network. So if you want to connect a devices by using the address like this, so device address like this, it can connect around 8 into 8 into 8. So that means if you are using 2 to the power of 8 bits of concepts in the form of 2 to the power of 8 bits. So the first domain ID will be having around 239 domain address. So the other addresses is used for the reserved one. We will discuss that, as well as it is having 256 areas. So and another 256 ports, 256 port we are using. Total around 15,663 15 crores 563 for like that. This is the number where we can connect the devices. That means this many number of connections can be connected by using a addressing. Okay, like that we can classify the addressing of each devices in the storage area network with many infrastructures. As well, the next thing is, not only we are connecting the devices along with the addresses, we are connecting our addresses along with the domain name address. Okay, so we are connecting the things along with the domain name World Wide Web. Okay, World Wide name. So that means this worldwide name is used for connecting the identifying the devices in the networks. Okay, while we are connecting the node into a infrastructures, we are connecting by having worldwide node name and worldwide port names like that with the unique address. Okay, each device is having the unique address which contains a format types, okay, and then company ID and the port number and model seats like that, if it is in the domain name arrays. Okay, if the storage array is connected with the domain name, storage array will be connected with the domain name, and storage array and the host ID is connected with the host ID will be connecting with the one more bit by the name called worldwide name. So like that we can connect two types of names like that. Now let us discuss fiber channel frames. Okay, how the fiber channel is having the frames. Okay, that means we have to convert our data into a different types of frames. The frames is divided into 5 groups. That means we have a data fields. So this is the data we need to transfer from one field, one location to the another locations. These data locations may be transmissions around 0 to 2112 bytes like that. Okay, each data fields will be added with the frame headers as we show it in the diagram in the frame frame stack like that. This frame header contains 24 bytes of frame headers. These frame headers contains the starting point. Okay, so this frame header contains start of the frames as well as the end of the frame. Okay, this is the end of the frames. So these start of the frames should be of 4 bytes. Okay, and end of the frame of another 4 bytes. So the next one we have a CRC code, that means cyclic redundancy check. So it is used for checking the error at the physical levels. Okay, these header can be have with the different aspects. Okay, so different aspects in the sense that it should contains a different control statement. Okay, receiver control statement. Okay, and this is one of the control statement which we are using it, and we have to tell what are the types of headers are having. Along with that, we need to convey the information of destination address. Okay, destination destination ID as well as source ID. Okay, source ID, and we have something called F control. Okay, along with that we have F control. Along with, this is the one. Along with that we have sequence number, sequence control, sequence ID, as well as DF control, and then sequence count, sequence count. So along with that, offset address. Offset, you know that offset is the end address. For example, if you want to have a data, if it is 00, and if the data wants to store here, from here to here the data, this is nothing but a offset things. Okay, that means we need to have a frame head with the different control messages like this. So where R is used as a root control, that means if you want to transfer from one node to the another node in the switches, we need to have root control. And if you want to tell that in what type of class the data is transmitted, for example, we have class A, class B, class C data centers, depends upon the services which is provided. So we need to classify the type of frames. Okay, which type of a frame it is, whether it is a class A frame or class B frame, like that. So, and we have something called type. So this type is used for defining the frames. Okay, which type of frame it is, whether it is a busy frames, or it may be a event frame, or it may be a signal frames, like that. It's having some numbers, something like that, 8, like that. So it will tells about whether this type is a small computer, simple interfaces, or some advanced interfaces, like that. And D frame is a data field frames. So it indicates that whether the header is having a whether the payload is having a data or not. Sometimes some data which is transmitting is an information data we are transmitting. Sometimes we are transmitting the actual data. It indicates that whether it is having a data or it does not having the data. And F frame is used for frame control while transmitting the data. Any bits are has to be changed, in what way the exchange of data is transmitting from one place to the another places, like that. Okay, so while transmitting the data, we need to transmit the data in this format, in the form of fiber channel frames. These fiber channel datas can be transmitted to in the transport layers. Okay, these transport layers uses a concept called sequencing or exchanging as well as framing. Okay, exchanging the means like exchanging the information means from between the two ports, it shares the informations, and sequencing means it's a continuous operations. There is an intermediate ports are present for transmitting the frames, or else it uses just frame control while transmitting. By using the header informations, it will transmit the data from one place to the another places. Next, let us discuss how actually the flow control will be done. Okay, while we are transmitting the data from the server by using the fiber channel storage area network to the data centers, we need to use some control operations, flow control operations. These flow controls will be done in the frame header fiber frames, fiber channel frames only. Okay, this is a frame control bit. So while using the frame control bits, we are using a two types of mechanisms. One is buffer to buffer credit mechanisms. That means while transmitting the data from one source to the another sources, we know that the transmission speed is very high and the receiving speed is very low. For that we need to have a buffers, okay, in the receiving side, okay, and then we have to transmit the information. The such type of transmission is called as B2B credit, B2B credit transmissions. Okay, the B2B credit transmission files. So in these type of mechanisms, it can transmit maximum number of frames without any break in the switches. Okay, so it is used for managing the frames in the switches between the two ports. Okay, and we have something called end-to-end credit. So this is the second method of flow control, end-to-end method of flow controls. In that end-to-end method of flow controls, we are using the similar approach of this, okay, B2B credit, but it is an extension. Okay, it's having an extra port login. Okay, whenever we are communicating between the one computer, one host machines to the another host machines along with the switches, it is communicated along with some ports. Okay, this is having an extra port for connecting, for extending the machines. Okay, for example, this is take the this is take the buffer to buffer connections, whereas end to end connections, extra devices has been used for flow controls. These type of flows will be used. End to end credit flow controller is used for the class A and class 1 services. Okay, so now let us discuss what are the different, what do you mean by classes. Okay, what do you mean by class? Okay, classes of services. So as I was telling that whenever we are using of communications between the host machine as well as the servers, we need to have different types of classes. Okay, like class A, class B, class 2, C, like that. So in class A we can connect more number of devices but less storages, and class C we can connect a moderate number of devices and moderate number of storage area along with the minimum storage area network. In some cases we have a large number of storage area along with the minimum number of devices are connected, like that. So we can classify the fiber channel standards into different services, depends upon the requirements of using of the services of the storage area network. Okay, so the class 1, so here we are defining class 1 service and class 2 services and class 3 services. So each class 1, class 2, class 3 services having some services patterns, depends upon the communication capability. For example, if you are checking that what is the communication capability of class 1, so the class 1 will be having dedicated connections. Okay, it's having the dedicated connections. So it is not having a dedicated connections, since it is connected along with the intermediate node with for performing a large number of connections. We are not having a dedicated node, depends upon the intelligence of switch, the connections will be done. Here also while connecting to the class 3, it does not have dedicated connections, it is connected through the intelligent switch itself. Okay, so now what is the flow control is been done in the class A. In the flow control in the class A is done through end-to-end credit. Okay, end-to-end credit, that means it's having an extra devices for performing the connections, end-to-end connections flow for controlling operations. Here in class 2 it contains both end-to-end credit as well as bus to bus credit. That means it's having the corresponding buffer between the connections. It contains both the things. Here it contains buffer to buffer credit of connections, okay, between the class 3. In the frame acknowledgements, whenever we are transmitting the data, there should be an acknowledgement of the frames. The frame acknowledgement means like the transmissions is been received or not, it has to be informed by sending the acknowledgement messages. So in the class A, it is having an in order, it's having an acknowledgement, but here having acknowledgement, but in the class C it not having the acknowledgement. Okay, acknowledgements, it's having the acknowledgements, it's also having the acknowledgements. In the class 2 also having the acknowledgement. The frame delivery is in the form of, the frames are delivered in the class A will be in the form of in orders. Okay, in order delivery of the frames is been done in the class A, and it is done in the form of ordered forms, but not guaranteed. Okay, we can't trust that the data is transmitted or not, because it is connecting in the networks. Okay, not guaranteed. Here it is also transmitted in the form of order, and as well as it is also not guaranteed. Okay, guaranteed of transmission. This is the difference between the class A, class C and class 3 connections whenever we are talking about the services of the things. So next we have to differentiate along with the multiplexing. Okay, multiplexing means whenever we are connecting between the devices, it has to combine, we have to get the transmissions from the things, and we have to send it in a single line. So in a class A there is no multiplexing operations will be done. So in the class 2 there is a multiplexing, and class 3 there is a multiplexing. Like that we can differentiate, and the bandwidth utilization in the class A is poor, because we are connecting to the dedicated devices, okay, with the end-to-end credit having, and it should have an acknowledgement in order, and multiplexing we are not using. For that it is a poor bandwidth. But in class A and class 2 and class C, we have a moderate, class A is a moderate bandwidth. It is having the high bandwidth, since it is having a B2B connections and no dedicated, and acknowledgement is not required like that. Okay, so this is the services of classes we are going to discuss. Next we have to discuss about what do you mean by fiber services. What are the different types of fiber services? So we have a fiber services of dedicated user names like that. Now let us discuss what do you mean by fiber services. Okay, fiber services. So whenever we are connecting to the devices, so one devices to the another devices, these one devices to the another devices are connected in the form of some addresses. Okay, so we have an address, something called fiber login address. We need to connect with the fiber address login servers. Okay, these fiber address login servers will be connected with by the address by the name called FFFE. Okay, similarly this server has to connected with the fiber controllers. Okay, fiber controllers. This fiber controller is once again connected with the address by the called 5D F, and these fiber controllers next is connected with the fiber servers, okay, for name servers, okay, will be connected with the named servers. So in the network, named server in the network, these fiber in the named server in the network will be indicated with the address by the name called C, and we have a management servers, management server. So this management server will be having the connections with the address by the name called A. This is the fiber services which is provided, where if you want to connect between the fiber channel along with the networks, we need to have a fiber logins by the address like E. Similarly, if you have a connections between the different ports, we need to have a controller, server name, and managements. So these addresses will manage us different types of switches, okay. So we are connecting different switches. So these switches may be will be connecting with these type of things. Assume that we have a switches, switch 1, okay, and switch 1 will contains a login servers and login server address and fiber controller and name server and management servers. Like that, there are many switches we are using it, okay. So in the infrastructures for connecting between the host machine as well as the data centers, many switches we are using it. These switches are connected with the network, okay, along with the different services like this: fiber channel login, fiber controller, name servers, and server managements, like that, okay. This is how actually the fiber things will be done. While we are connecting the management, okay, fiber channel management, we need to have a secured transmissions, okay. So secured transmissions will be done by the concept called zoning, okay, by the concept called zoning. The zoning concept is used for used for securing our infrastructures. For example, we are connecting a servers like this, okay. This is the server which we are connecting. These servers are connected along with the storage fiber channel storage area networks. This is connected to the fiber channel storage networks for the storage arrays, okay. This is the storage arrays, that means the data centers. If the server wants to connect with the data centers with the fiber channels, so it has to connected along with different dedicated networks, okay. So these different dedicated networks will be connecting along with the group of zones, okay, connecting along with the group of zones. What do you mean by this? What is the purpose of connecting the server to the data centers along with the group of zones? Because if you are having a control messages, as I told that if the server wants to participate for storing the information through the storage area networks, it should have a unique ID and it has to perform the registrations, okay, and the registrations is done through the dedicated lines. While registering new devices to it, it should have has to know these devices. The other devices should know that what are the devices has been connected through the management servers, okay. If we are transmitting these management control informations for the networks for making the registration purpose, the other operations like transmitting the data from server to the data centers may be congested, okay. For that purpose, instead of transmitting the data to the whole network, we zone the infrastructures into a different areas, and then we make connections, okay, between the things, okay. While we are making such type of connections, we have to follow certain levels of zoning. Okay, that means we call it as zone sets and zone area and zone members, like that. So we can divide the zone types of the zones. Okay, types of zones into different sectors. One is called as port zones. Okay, port zones, that means in the port itself. Okay, while the port, this is the port, for example, if you have a switches, and if the one as I told that whenever we are connecting with the one devices to the another devices, we are connecting to the port itself. If the zoning is done through the port levels, okay, between the two port level, is called as port zones. That means the physical address switch ports are connecting between the one devices to the another devices is called zone port. This is the one type of zone type. The second type of zone ports is worldwide name. Okay, and we know that worldwide name is one more address we are using while the infrastructures connecting to the storage area network at the network level. Okay, so we need to have a network level zones. Okay, network level zone by the name called worldwide name zone. So this is the address is given at the host bus adapters, is given at the host bus adapters, or else at the target levels. Okay, whenever we are giving a zone at the host bus adapters or else at the target levels, we are giving a zone type by the name called worldwide name zones. Okay, and the third one is a mixed type of things. That means either we can give the zones, mixed types of zoning. Okay, either we can give a security at the port level, or in some cases port level as well as the network level by using WWN. Okay, worldwide naming zones, both the combinations we can give. Like that, the type of security for making the registrations and transmitting the data in a secured path itself, we can classify the security operations. This type of operations is done for managing the servers. Okay, there are different types of servers are available for connecting. Okay, this is one type of things. And next we have to discuss about the fiber channel topology. The fiber channel topologies can be of we know that whenever we are connecting to any network, we need to connect along with the standard topologies. Okay, so we need to have different types of topologies, something called mesh type of topologies. So these mesh type of topologies are connecting between one network to the another network along with some dedicated infrastructures. That means we have a servers. This server is connected to the array of storages along with the different types of hubs. Okay, different types of hubs as well as the switches are connecting like this with the dedicated switches. Okay, so or else we are connecting along with the full mesh type of devices. Okay, half mesh, partial mesh. This is the partial mesh type of connections. And if it is a full mesh of connections, full mesh of connection is done through the switches, only switches. It uses only switches for connecting between. Instead of hub, it uses switches for connecting, so that it will be connected to all the devices. But in the hub we can't do the cross connections. In the switches only we can do the intelligent switches like that. And second type of connection is done through the core edge switching. Okay, topology. Second type of edge is core edge fibers. Okay, core edge fibers types of connections. In the core edge type of connection, two-tiered switch connections will be done. Two-tiered switch connections means like here in the mesh type we are connecting with the switches. In the core edge type of connection we are using a two-tiered switches. That means we have a switches like this, which is a group of switches along with one directors. Okay, as I was telling, that director is for the extended for connecting between the server as well as the storage arrays. Okay, this is a storage arrays, so we need to connect between one switches, and these switches are interconnected, and through the directors it is connecting to the network. This is the type of connection which is called as a core edge fibers. Like that, the topology of connections between the server as well as the storage area networks along with the hubs, which is called as partial meshing, and full hub, which is using by only switches for connecting between the host machine as well as the storages, or else we are using something called directors along with the switches and special dedicated switches, which is called as a core type of core edge topologies. So this is the things. Next we have to discuss about what do you mean by block level virtualizations. So the word block level virtualization is used for making our storage area virtualized. Okay, block level storage virtualization. Block level storage virtualizations. So what do you mean by that? What do you mean by block level storage virtualization? So block level storage virtualizations can be done by LUN, okay, logical unit numbers. Okay, all the devices which is connected in the storage arrays are being identified with the logical fashion. For example, we have a storage arrays like this. So arrays of storages are present. These arrays of storages are presented in the different networks. This is the arrays of storages. These arrays of storages in the networks will be having an address. So these all the things will be having an address, and it is being integrated like this. This is one type of logical unit number, okay, which is not actually the physical one. So I have discussed in the first unit. This is the logical unit numbers. These logical unit numbers is in turn will be converted into a single number by using a fiber channels. So these in turn will be connecting to the servers, okay, where the server will be connected. So different servers, server 1 and server 2, like that we can connect. This is nothing but the fiber channel storage area networks. That means if you want to make our storage array to be virtualized, okay, virtualized at the block levels, okay, at the network level, we have to have a virtualization volume, okay, virtualization volume at the network level. That means even the storage arrays which is present in it can be made it virtualize, a pool of virtualization, and then we can transmit it. Such type of things is called as block level storage virtualizations. A group of storage area networks are sharing the informations in the network layer for extending the services for the network is called as block level storage area networks. This is one thing. This is, or else we can make it a group, okay, we can make it a layer like this. Each layer will be divided into different groups, and then also we can share for the different services. So like we divide, this is area 1, so where it can share only these services for this server by making a group. Like that we can make a group. This grouping is done along with the internet protocols. Okay, so we will discuss the fiber channel internet protocol. So we will share that information in the next class regarding the fiber channel internet protocols. Next we need to discuss about virtual storage area networks. What do you mean by virtual storage area networks? The word virtual storage area networks is used to virtualize the fibers only. That means instead of having a dedicated fiber channel wires, we can make virtualization operations by using a fiber channel. That means we can develop a software part of the fiber channel which we are generated, and then we can make it. That means we can enable the connections itself by using different techniques of virtualization concept, and then we can enhance the virtualization concept. Okay, such type of, that means like we have a fiber channel connection. This fiber channel connection itself has been developed a software for making and this software will be treating as a fiber switches. Fiber switches. Okay, so that means through the software itself we can develop a switches and we can transmit it. That means copy of it. That it's a logical switches. This is the logical switches is called as virtual SAN. Okay, so this is how actually we have come across with the concept, starting from how the fiber channel architecture has been developed with the different layers, fiber channel 4, fiber channel 3, fiber channel 0, like that, with the physical infrastructures. And then we have discussed about the topology of fiber channels, and we discussed about how the virtualization concepts has been done in the storage fiber channels for making extension of the things. So this is how the third class I am ending the session. Thank you so much.